Now it's your turn to solve quadratic equations using the square root method. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this first equation, we're given 5x squared equals 100. So to solve this for x using the square root method, we're going to want to isolate x squared. Note that because we have 5 times x squared, the 5 is not part of the squared piece here. So it's just x that's been squared, and we need to isolate that. So in order to do that, let's take that 5x squared, that's equal to 100. And so as our very first step, we want to divide each side of that equation by 5. So I'll have 5x squared, we'll divide that by 5, and then that's equal to 100, which will also divide by 5. Now, we just have x squared on the left-hand side, and that's equal to 100 divided by 5, which is 20. So we have x squared equal to 20. At this point, we're ready to apply the square root property. So from x squared equals 20, we can now write x equal to the positive or negative square root of 20. The square root of 20, as a radical, we want to check if that can be simplified. When we do that, we're going to look to see if it has any perfect square factors. 20 has 4 as its largest perfect square factor, so we're going to simplify this radical using that. So now we'll have x equal to the positive or negative square root, and we'll write this as 4 times 5 inside that square root. And so now we can simplify that one step further, and x will be the positive or negative square root of 4 times the square root of 5. And so that'll give us x equal to the positive or negative 2 times the square root of 5. So we have positive 2 times the square root of 5, and then we have negative 2 times the square root of 5. Those are the two proposed solutions. We'll check these really quick. We'll check the first one. And so we'll replace x with 2 times the square root of 5. So doing that, we're going to have 5 times, and then inside parentheses we'll have 2 times the square root of 5, quantity squared, and we're checking if that equals 100. Simplifying what's inside those parentheses and then squared, we'll use the properties of exponents, and we can have 5 times, then this will be 2 squared times the square root of 5 squared. We're checking if that equals 100. Simplifying this one step further, we'll get 5 times 4 times 5. And multiplying that through, that indeed equals 100. Our second check will look very similar, except that we'll have a negative. So replacing x in the original equation with negative 2 times the square root of 5, we'll have 5, and then inside parentheses, negative 2 times the square root of 5. And that quantity is squared, and we're checking if it equals 100. Applying the rules of exponents again, we'll have 5 times the number negative 2 squared times the square root of 5 squared, and we're checking if that equals 100. There are a couple different ways that exponent rules could be applied here. This is the route that I've chosen, but there are a couple other ways we could get to simplifying that left-hand side. From here, we're ready to write 5, and then negative 2 quantity squared is 4, so we have 5 times 4, square root of 5 squared is simply 5. 5 times 4 times 5 gives us 100 again, so that checks. So now we're ready to write our solution set, and it contains two solutions. We have 2 times the square root of 5, and we have negative 2 times the square root of 5. All right, in part B, the equation that we're given is the quantity y minus 11 squared minus 36 equal to 0. So to solve this using the square root method, we're going to need to isolate the squared part, which is y minus 11 quantity squared. In order to do that, so let's write our original equation down. We have y minus 11 quantity squared minus 36 equal to 0. To isolate that y minus 11 squared, we'll need to add 36 to each side of this equation. So from there, we'll have y minus 11 quantity squared minus 36. We'll add 36 to the left-hand side. And then we'll also add 36 to the right-hand side. From here, our left-hand side will simply be that y minus 11 squared. So that quantity y minus 11 inside parentheses and then squared, and that's equal to 36. Applying the square root property, we can now write that y minus 11 is equal to the positive or negative square root of 36. Now, the square root of 36 is simply 6, so this simplifies to y minus 11 equal to positive or negative 6. To get y on its own, we'll then add 11 to each side, So y minus 11, we're going to add 11 to the left side, and then that'll be equal to positive or negative 6, and we're going to add 11 to the right side. So now we have y equal to positive or negative 6 plus 11, and we want to simplify these. It'll be helpful to break this apart into two separate solutions. So we have y equal to positive 6 plus 11, or we have y equal to negative 6 plus 11. The first one, y equals 6 plus 11, is simply y equals 17. And then our second one, which is y equals negative 6 plus 11, is simply y equals 5. So now we have two proposed solutions, 17 and 5, and we can check each of those fairly quickly. We'll replace y in the original equation with 17, and we'll see that we then have 17 minus 11 inside parentheses, and that's squared. We're subtracting 36, and we're checking, does that equal 0? 17 minus 11 is going to give us 6. We have 6 squared minus 36, and of course that does equal 0. For our second check, we're going to replace y with 5, and so we'll have 5 minus 11 inside parentheses, and that's squared, subtracting 36, and we'll check, does that equal 0? What's inside parentheses will then simplify to negative 6, so we have negative 6 inside parentheses squared. We're subtracting 36, and we know that negative 6 when squared is positive 36, so that also equals 0. So we've checked both of those solutions, and now we can state our solution set. The solution set contains the numbers 17 and 5, and I'll write them as 5, 17. With sets, the order doesn't matter here, but I'll write it in smallest to largest either way.